Hey, I'm Austin Zilke, and I'll be discussing the manufacturing process for an Overlander camper. First things first, what in the world is that monstrosity of a vehicle? It was definitely the first thing I thought, seeing one of these beasts in person. An Overlander is basically a vehicle equipped to suit the needs of adventure travelers. Currently, the biggest name in the Overlander business is Earthroamer, who boasts about being the global leader in luxury Overlanders. They've been in business since 1998, and currently their model offerings are the HD and LTI. The HD is built on a Ford F750 chassis and has a length of 35 feet, a width of 8.5 feet, and a height of 13.2 feet. The HD is available starting at the low cost of $1.7 million, but good luck getting one, as the waiting list is likely quite backlogged. Earthroamer's newest rig is the LTI, which utilizes its one-piece carbon fiber camper body as a main selling point. It's a bit smaller, with a length of 29 feet, width of 8 feet, and height of 12 feet, and costs anywhere between $650,000 and $700,000. The manufacturing process of the carbon fiber camper body uses a vacuum infusion process to bond two carbon fiber skins to a structural foam core. Another term for this is a monocell, or double composite structure. Take note of the capacities of both of these rigs. They both can store a lot of water, a lot of fuel, and they both have huge power banks. And also, with all the insane storage capabilities of them, they're both extremely massive, and they kind of dwarf every other thing on the road. Now, while Earthroamer has had a stranglehold on the luxury Overlander market the last few years, up-and-coming Truckhouse has a promising platform to dethrone the king. Founded in 2019, Truckhouse ties their inspiration for the new BCT back to smaller 4x4 campers of the 80s. I actually discovered the BCT through the Composites Manufacturing Industry Digest email that Professor Miller sent out in January, and was instantly intrigued. Introduced at the beginning of this year, the BCT is designed to conquer the niche luxury market for two reasons. Firstly, it is built on a Toyota Tacoma platform, a highly regarded vehicle for its reliability and capabilities. Secondly, it fills a much smaller footprint, having a length of 22 feet, width of 7 feet, and a height of 10 feet. This allows for much easier handling on and off road. I mean, good luck getting an Earthroamer up some of the narrow forest service roads in Montana. Well, it doesn't have the storage capacity of the Earthroamer. It seems like a much more realistic vehicle for overlanding. Furthermore, the cost starts at a mere $285,000, so you don't need a trust fund to buy one. Similarly to the Earthroamer, the BCT utilizes a carbon fiber reinforced monocell. This likely means that the majority of the reinforcement is fiberglass to keep costs down, but it does have some carbon fiber in there for a little extra pizzazz. I could talk about Overlanders forever, but the next category I'd like to jump into is the do-it-yourself approach. Many people have attempted to make their own Overlanders, often constructing them from an aluminum or wood camper body. Perhaps the best method I've discovered is using composite sandwich panels for the camper body. These are usually made from a fiberglass outside skin, an insulating foam core, and a polyester or fiberglass inside skin. Sandwich panels are primarily used for their ease of only needing to perform secondary manufacturing operations, which most do-it-yourselfers have the ability to do in their own garages. These prefabricated sandwich panels do have their downsides, which is why the top-of-the-line Overlander companies utilize double composite construction. Before I jump into the manufacturing process, I'd like to highlight reasons why composites are used for Overlander campers. Firstly, the one-piece design of a monocell allows for superior moisture protection, a big issue in conventional campers. The lightweight nature of composites allows the rigs to have more capacity for gear, or fuel, or water, or even power systems. Next, the protective gel coat is much more forgiving against racing stripes given by trees than metal, and provides for better repairability. Carbon fiber also has superior thermal properties regarding thermal expansion and the like, and the sandwich core between the skins offers great insulation abilities. The strength of the composite skins provide great impact protection, and finally, the moldability of composites gives designers the ability to create sleek and complex geometries. Okay, so a big challenge for many leading-edge composite manufacturers are keeping their manufacturing systems, material selection, and material systems a secret. Both Earthroamer and Truckhouse are no exception, and have all of their proprietary information and industry-leading processes on lockdown. So I decided that the most interesting way to go about highlighting the material systems and manufacturing systems is to discuss how I would replicate the Overlander camper manufacturing process. For material selection, a carbon fiber prepreg is the best choice for the reinforcement. The fiber directions of the carbon fiber prepreg are optimized for best overall strength and rigidity for the camper structure. The matrix used is the epoxy integrated into the prepreg, and the specific material I chose for this scenario, I used a unidirectional carbon fiber prepreg, and that contains about 38% resin by volume. A clear gel coat is also needed for better UV protection and to provide the best surface finish. For the monocell sandwich material, I used an aluminum oxide ceramic foam, which offers great insulating properties and also has great machinability. Other material considerations include mold release, adhesive, and vacuum bags. Other presenters have brought up various material suppliers, but for my material selection, I reference fiberglass as it offers ease of access to the general consumer. For such a huge structure, multiple molds are required, and these molds are creating preforms. An Overlander camper would likely require molds for the left side, the right side, the rear, above the truck cabin, so the bed enclosure, the roof, and the floor. Furthermore, because it utilizes a sandwich construction, and also for keeping the preforms in shape, both molds for the inside and the outside of the sandwich are required. Each mold must also be designed with consideration to the assembly of the final one-piece camper. For designing an Overlander camper, I chose rough dimensions of 15 feet long, 7 feet wide, and 8 feet tall. This is pretty comparable to the BCT, and this provides a total rough surface area of 63 square yards. So this surface area must be covered by the carbon fiber prepreg fabric. Assuming that the exterior is made up of 6 plies of carbon fiber and the interior is made up of 4 plies of carbon fiber, the total cost for covering the surface area with 10 total plies of unidirectional carbon fiber prepreg is just over $50,000. A protective gel coat is $650 for 4 gallons, mold release is $85 for 4 gallons, and epoxy paste bonding adhesive is $690 for 6 quarts, and this is what connects the carbon fiber skins with the aluminum oxide ceramic foam. I was unable to find cost estimates for the aluminum oxide ceramic foam. The best I could find was a website selling 2 pieces of foam of an unknown size for $160, so it is assumed that the foam core will likely be more expensive per square yard than the carbon fiber. Here's the manufacturing process that I would develop in order to manufacture overlanding campers. First, both mold sides would be coated with mold release for ease of removal. Next, a gel coat would be spread over the molds to produce a thick protective layer. The exterior carbon fiber prepreg plies would then be added to the mold in desired orientations. The ceramic foam sandwich material would be machined to match the contours of the molds, and then would be adhered to the exterior carbon fiber plies. Next, the first interior carbon fiber ply would be adhered to the ceramic foam, and then the rest of the carbon fiber plies would be added. Finally, the inner mold would be attached and clamped, and using a vacuum and pressure, the preforms would be created. Each preform would be removed from the molds and then assembled into the camper body assembly with carbon fiber plies overlapping where each piece connects. Assembly molds and specialized assembly tooling and fixtures would be required to make sure this process goes smoothly. The assembly would then be vacuum bagged and placed into an autoclave to cure. Once cured, the assembly would be removed from the molding and tooling, and finishing operations would be performed to get it to its final state. Here's the only footage I've been able to find about the camper manufacturing process at Earthroamer. While short, it provides important insight into their design for turning multiple pieces into a single piece monocell. Let's see if I can get to it.
Hand welded, put on by hand. The bodies are all laid up by hand. There isn't a single piece of this truck that we don't touch. with our hands right here in America. A lot of people say it's made in the US, made in America, but they've got components from everywhere and everything's pre-assembled and they just kind of assemble something. We do much more than assembly. We put heart and soul into the things we build.
So there's 10 seconds of greatness. Okay, here's a visual of how the exterior carbon fiber plies would be placed into the mold after the gel coat. This process, shown in the image, just uses the carbon fiber fabric rather than prepreg, but for the layup it's practically the same procedure. Here's a visual of how the sandwich layer is added. This image right here shows how the inner plies of carbon fiber creates the double composite structure, and I think this is just a really cool image for being able to visualize the monocell. Regarding quality control, the usage of prepregs keeps the fiber volume ratio extremely consistent, which is very important for the structural properties of the final camper. The development of preform molds and assembly tooling and fixtures allow the final structure to be consistently produced. Hand layup of the carbon fiber prepreg decreases consistency, but many tools, including lasers, can be used to improve the accuracy. The usage of a vacuum and autoclave process helps to reduce the amount of voids in the final composite structure. And after being completed, it is extremely important to make sure that the camper is completely waterproof, but the one-piece design aids greatly in assuring that. There are many design implications that come with this manufacturing process. Firstly, the usage of prepreg carbon fiber comes with many benefits. They are easier to use with regards to time, as they cure at elevated temperatures and often can be kept and manipulated at room temperature, so workers don't need to worry about their resin gelling before finishing the layup. This is super important for such a large structure, requiring many preform molds before being combined into a singular assembly. In addition, prepreg fabrics allow for high fiber volume ratios and can achieve up to 65 to 70% fiber volume quite easily, which results in optimal strength at lower weights. Furthermore, prepregs are very consistent and don't rely on in-house mixing of resins or attempts at achieving specific fiber volume ratios. Prepregs are also a suitable material for low volume production and don't necessarily translate very well upscale to a high volume production, but that's not really necessary in this circumstance. Perhaps the biggest design consideration must be the assembly of the preforms into the one-piece monocell to make sure that stress concentrations aren't present where each preform piece connects. As an industry, Overlander camper production is a very low volume process. Earthroamer, which started in 1998, has produced slightly under 300 total Earthroamers since 2003. Their first version, a fiberglass one-piece camper body LT, had around 100 rigs produced, which was then replaced by the improved fiberglass LTS. Around 150 of those were produced. The HD was unveiled in 2017, and since then, 7 are currently on the road and 3 are in production. There's probably more than that right now. The LTI was unveiled in late 2019, and 15 are on the road, and an unknown number are in production. From my research, I found varying rates of 12 to 25 Earthroamers being produced per year. However, the current production rate is unknown. And then with Truckhouse being such a new company, and the BCT being unveiled at the beginning of this year, it is unknown if or how many are currently in production. But I believe they started at the beginning of this year, and hopefully they'll be on the road in no time. Here's the Earthroamer manufacturing facility. It's a huge 40,000 square feet of space, which provides enough room for the complete manufacturing and fabrication processes of the whole Earthroamer. As a contrast, here's the Truckhouse manufacturing facility. It's only 5,000 square feet, which is 8 times smaller than the Earthroamer facility. This means that initial production runs will be smaller until the BCT is able to root itself into the Overlander market, and then there will be room for expansion in the future. Earthroamer currently has over 80 employees, and I would guess that around 15 to 20 work with manufacturing the carbon fiber camper. Truckhouse's workforce is unknown. With the manufacturing process that I have in mind, I believe an optimal workforce would be 15 people involved in manufacturing operations and 2 to 5 people involved in design operations. There are many capital investments required to produce Overlander campers using this process. First and foremost, a big enough manufacturing facility is needed. In addition, to cure the prepreg carbon monocell under pressure, a massive autoclave is needed. I was unable to find any prices So they're likely extremely expensive for one big enough to fit the whole camper. Molds are another huge investment required. A CNC to machine the ceramic foam to the desired sandwich shape is another big investment, but adds repeatability over hand shaping the foam and reduces time greatly. A significant investment must also be made for assembly tooling and fixturing to produce a repeatable one-piece construction of the camper, and due to the size of the camper, scaffolding and other mobility fixtures must be used for ease of assembly. There are various possible hazards and dangers present in the manufacturing of overlander campers. Luckily, prepregs remove lots of potential volatile organic compounds from the environment. However, there is still a hazard from the gel coat, mold release, and adhesives used. A closed machining environment must also be used for the ceramic foams, as ceramic particles are a breathing hazard. In addition, moving the large and heavy preforms into the assembly is potentially dangerous, along with using scaffolding and other assembly fixturing. An autoclave also adds dangers involving heat and necessitates being properly closed to maintain pressure. Thanks for watching, and here are my sources.